Hello viewers, with me here I've got this question on geometric key progression. So it is a question 3A from a 2021 internal math paper 2. So follow through as I work out this question. So it reads, the second and fifth terms of a geometric key progression are 16 and 2 respectively. Find Roman numeral 1, the common ratio and the first term. So this part has 3 marks. Then Roman numeral 2, the 12th term. So this part has 2 marks. Then Roman numeral 3, the sum of the first 10 terms. So this part has got 2 marks. Starting with the first part, the common ratio and the first term. So for common ratio and first term, we are just going to use the information given here. The second term of this GP is given as 16. The fifth term of this GP is given as 2. So first of all, we're going to start with writing the general formula for calculating terms of a GP. So the formula is given. Roman numeral 1, it is Tn equal to A R n minus 1. So power n minus 1 for r. So Tn equal to A r to the power n minus 1. So given that formula, we start with 16. 16 is the second term. So we are going to indicate 16 as T2 equal to 16. Then for 2, fifth term. So for this one, we're going to say T5 equal to 2. Now we're going to come up with 2 equations, okay, from this, using these 2. So T2 is equal to 16. So this means that T2, which is 16 here, is equal to AR. N is 2. So 2 will subtract with 1. Okay, so for the first equation, we're going to have 16 equal to AR power n, which is 2, then take away 1. So 16 equal to AR 2 minus 1 is just 1. And r to the power 1 is the same as r. So here we're going to have AR, and this is our equation 1. So from equation 1, we've got it from Tn equal to AR to the power n minus 1, and using this T2 equal to 16. So now we get equation 2 using this, and also T5 equal to 2. So for T5 equal to 2, this means that this is T5, which is the same as 2. So 2 equal to AR, which we don't have, to the power n. N here is 5. This is the fifth term. So 5 take away 1. Can show it here. 5 take away 1, which will basically give us the following. AR 4. So AR to the power 4. So this here is our equation 2. Then to work out these two so that we get common ratio and the first term, I'm going to pick on equation 1, and I'm going to let A the subject. So this gives us the following. If we let A the subject, this will give us the following. So we have 16 equal to AR, and if we divide by R, both sides, R and R this side will simplify, giving us A equal to 16 over R. So this is what we get, and we're going to call this as the equation 3. Take note of that. So then, substituting equation 3 into equation 2, this is going to give us the following. 2 equal to, on A, we're going to put 16 over R. So 16 over R. And this is going to multiply with the r to the power 4. So r to the power 4. Now r and r to the power 4 can simplify. So r into r, 1. Then r to the power 4 divided by r. This will just give us r to the power 3. So what we're getting is this. 2 equal to 1 into 16, that is just 16 here. then r to the power 3. We want the value for r, which is the common ratio. So we are going to divide through by 16. This will simplify, leaving us with r to the power 3 equal to 2 over 16. Then we can simplify 2 and 16. 2 can go into 2, that is 1s, and 2 can go into 16, 8. So what we have is this, r to the power 3 is equal to 1 over 8. And to get r, if you've seen it has got a cube, so we are going to introduce cube root. So cube root, both sides. Cube root and cube will simplify, leaving us with r here. And then, what is the cube root of 1? Meaning a number that multiplies 3 times to give 1. So this is just 1. Then over a number that multiplies 3 times to give 8. That is just 2. So r is equal to 1 over 2, or just simply half. So since we've gotten r, we can now get a from equation 3. Remember, equation 3 was given like this. Equation 3 was given a equal to 16 over r. This was our equation 3. So on r, we're going to put 1 over 2. So this is going to be a equal to 16. This is more like r is dividing into 16. So 16 divided by r can also be written like this. So 16 divided by r, which is this one, 1 over 2. So to solve this one, we'll simply change the operation here. So a equal to 16 over 1 times. So 2 goes up, 1 goes down. So they'll reciprocate. So you're going to have 2 then over 1. And 16 times 2 gives 32. 1 times 1 gives 1. 1 into 32 is just simply 32. So a is equal to 32. R is equal to 1 over 2. So let's take note of these two values. R is 1 over 2. A is 32. 3 marks for all this process. Then Roman numeral 2, the 12th term, 2 marks. So for the 12th term, taking note of what we've calculated, so we're saying, first of all, r is equal to 1 over 2, then a is equal to 32. So taking note of these two, Roman numeral 2, the 12th term, so we start with the general formula for calculating terms. So this is t n equal to a r power n minus 1. Now, 12th term, this means n is equal to 12. So we want the term that is on position 12. So this is t12 equal to a is 32. So we write 32 here, open bracket, 1 over 2, which is r. Then n, which is 12. So 12 take away 1. So t12 is equal to 32, open bracket, 1 over 2. What is 12 take away 1? This gives 11. So now, what is 1 to the power 11? So 1 to the power 11 is just simply 1. Then 2 to the power 11. 2 to the power 11 can be calculated using a calculator. So all we just simply type is 2 to the power 11. So this gives it 2048. So that's what we get, 2048. So here we write 2048. So 1 over 2048. And for this one, we can simplify, because the 32 and the 2000, 32 can go into 32, 32 can go into 2048. So what I'll write is the following. T12 is equal to 32 over 2048. So this simply gives the following. So we can use the calculator for this. 32 over 2048. So this gives 1 over 64. So this here is the same as 1 over 64. So this is the 12th term, 1 over 64. So 2 marks for this part. Then we go to the last part, Roman numeral 3, the sum of the first 10 terms. Let's calculate the sum of the first 10 terms, taking note also of the information that we have here. So for this part, what we just have to do is the following. First of all, the formulas are given on the second page, okay, of this question paper. So on the first page, there are two formulas, okay. The first two are for calculating sum, okay, of a GP. Then the third one is for calculating sum to infinity. Now for the first two, they've given conditions for R, okay. The first one, you have to use it when R is less than 1. The second one, you have to use it when R is greater than 1. So this means that our R here, which is 1 over 2, is less than 1. So this means we have to work with the first one, which is Sn equal to A, open bracket 1 minus R to the power n, then over 1 minus R. Now this one is where R is less than 1. That's the condition. So this is satisfied because of this situation that we have here. So Sn, meaning S10. S10 is going to equal to A is 32. Then open bracket. So for this one, I'm going to write square brackets, open square brackets, then 1 minus R, which is 1 over 2. So for this one, I'll write it as 0.5. R, which is 1 over 2, is the same as 0.5. So 0.5 to the power n, which is 10. Then over 1 minus R, which is also 0.5. So here we just have to work with the calculator. So we'll start with what is here. First of all, I will get 0.5 to the power 10. So just simply type 0.5 to the power 10. So this gives me 9.765625 times 10 to the power negative 4. So this answer, now 1 minus what we are getting. So 1 minus answer, what I'm getting is 0.999023437. So this means 32 is multiplying with 0.999023. So we can end there. Then over, what is 1 minus 0.5? So 1 minus 0.5 is just simply 0.5. S10 is equal to, what is 0.999023 times 32? So this answer times 32. So what I'm getting is 31.96875. So this over 0.5, so divide by 0.5, what I'm getting is 63.9375. So writing that, so S10 is equal to 63.9375. Now the instruction when we get a decimal number is that we leave our answer corrects to 3 significant figures, and here we've got 1, 2, 3, 4, 5, 6 significant figures. So this means that we want 1, 2, 3. Now dropping off 3 we'll add a 0 to 9. So this will just give us 63.9. So the answer is sum of the first 10 terms 63.9. So that's what we get for this part. So thank you so much for watching this video.